Hey guys, today's question is final prices within a special discount in a shop. In this question, we are given with the prices integer array, which denotes the different items and the prices for all the items are given at the prices I index. Okay. Now, this is given if there is a special discount for item in the shop. If you buy the ith item, then you will receive a discount equivalent to prices j, where j is the minimum index such that j is greater than I and prices j is less than equals to prices I. Okay. So we have to find for every index, we have to find the minimum index such that that index is right in the right side of the that element and the value of that element prices j should be less than equals to the current element. Okay. Otherwise we won't receive any discount and we have to return the final price of the item that we will get after considering the special discount. Okay. For example, in this case we can see 84623. For this 3 we don't have any element in the right side, so the output is 3 same. For this 2 we don't have any smaller element in the right side, so same here. For this C, the minimum index that we get, which is smaller, there are two smaller elements but the minimum is 2. Okay, this one, so the discount we'll get is 6 minus 2. We will get discount of 2 and the overall price after taking this discount will be 6 minus 2 equals to 4. Okay, now this 4, the smallest element will again be 2 in the right side. The first smallest element, that is the next smallest element. Okay, and for this 8, the next smallest element will be this element 4, so the discount will be 4 and the overall price taking the discount will be 8 minus 4 equals to 4. So we can see this array. Now we all know when we are taught about the to find the next greater or next smallest element, and is in this case we have to find the next smallest element for every point. Okay, in that case we have to use monotonic stack always whenever we see a problem talking about the next smallest or next greater element. We have to use the monotonic stack. Now how to use the monotonic stack is, we can say for this 2. Okay, for this 2 we need a smaller element in this side only. We don't need the greater elements. Okay, so for example, in the monotonic stack we have to find that we have to keep the elements in the increasing order or decreasing order. Firstly, when we have to find the elements in the right side, of course we will start the loop from the right side to the left side. Okay, and we will mark the discount for every element, and we will take, initially we will take a answer array also. Okay, that will store uh, that will store the that will store the prices, and then we'll simply subtract the discount. Okay, and also the right side element can be not greater, so the discount will be not greater than that element, so simply we don't need to check for the 0. Okay, now we will check that we have to keep the elements in the increasing order or decreasing order. Okay, now if we keep the elements in decreasing order, for example, like I take 3, okay, then take 2, and then I got 6, and yeah, we found the element smaller than that. And when I found that 6, I have to keep the elements in decreasing order. Okay, so I have to pop all these elements, but for this 4 we need the answer to be 2. Okay, so let's see if I what will happen if I take elements in increasing order. For example, if I take this 3, okay, then when I reach 2, I will pop out this 3 because this is a smaller element and we don't need any greater element in the right side. Okay, so while all these elements are bigger than this one, then we will simply pop them out. Okay, because we want the biggest element, so we will keep the elements in the increasing order. Okay. You can also do some what couple of dry runs to understand why we are taking a stack elements in the increasing order, but that's it. Now we have created the vector and stack, and let's run the loop. So for int I equals to, we have to start from the right side, so prices dot size minus 1, I greater than equals to 0, and I minus minus. Now also we need to store the indexes, not the elements. Okay, we will store the indexes. I think we can store the elements too. but we will store the indexes. It should be easier, I guess. So while not stk.empty, as I am taking the stack in the increasing order, so while stack is not empty and the element and prices and the element at that index, which is st.top, is greater than prices I. Okay, because we have to find a smaller or equal element. While this condition hold, we will simply pop the element out. So st.pop. Now our answer will update only if the stack is not empty. Okay, so if not st.empty, we have to update the answer. So answer I equals to max. So no, not max. We don't need to 0. Simply we will subtract the discount that we got, which is prices and st.top index. I guess you can also store the elements, not indexes only, but that's fine. It will also work. And every point, of course, we will push the current index and simply return answer array after the whole execution. Okay, let's submit this one. So the code is accepted. Thank you for watching.